Welcome back to Math 103. This is video number 23 on growth and finance. We're ready to compute the value now of this long sum. We have to substitute in the right values to our formula. This is the slightly tricky part. So it's straightforward that $3,000 is the amount of each payment. And since these are yearly payments, we need the yearly interest rate, and that is 7%. That information is just given to us. Where we have to think a little bit is the number of payments. Notice that there are 41 payments rather than 40. This is a common source of mistakes, so let's be clear why it's 41. Let's think of it this way. What if there were only 2 payments? What if we were doing this not until the age of 65, but only until the age of 26? Then you'd be making 2 payments, but the difference between the ending age and the starting age would be only 1. What if you made payments at the ages of 25, 26, and 27? Then you'd have 3 payments, but the difference between 27 and 25 is only 2. In other words, the number of payments is 1 greater than the difference between the ending age and the starting age. By the same thinking, if the ending age is 65 and the starting age is 25, the difference is 40, but the number of payments is 1 greater than that. It's 41. Another approach is to list all the numbers from 25 through 65. That's a lot of work, but if you don't believe what I just said, then you can always do this and see that there are in fact 41 numbers. A little shorthand here is to say that you've got numbers from 25 through 34. That's already 10 separate numbers. You can count them off. That's already 10 separate numbers. Just as there are 10 separate numbers from 1 through 10, not 1 through 11, but 1 through 10 is 10 numbers. Similarly here, 25 through 34 is 10 separate numbers. Then 35 through 44 is another 10 numbers. 45 through 54 is another 10 numbers. 55 through 64 is yet another 10 numbers, and that leaves 65 as the one left over. That means that there are 40 numbers plus 1 left over. That's 41 payments. After sorting out that one bit of trickiness about the value of n, we plug in n equals 41, I equals 0.07, PMT equals 3,000, and we simply compute. At the end of the day, the value of this long sum turns out to be a quite impressive number, $643,828.71. That's a rather nice chunk of change that results from saving a moderate amount of money every year. As a useful comprehension check, answer the following question before going on to the next video. Let's focus just on the first payment, the one made at age 25. So we're looking now just at a one-time payment and asking how much does this one-time payment ultimately contribute to this large $643,828.71 sum, the one that will have accumulated by the time you're 65. So this is the full value of the sum, and that contribution made at age 25 adds something to this sum. What does it add to this sum?